Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, yesterday we conducted the test on mathematics and science, and I am really very happy to share that I have got excellent response from many students. And another important thing is, the students who have not got the question paper, no need to regret for that, because now I am going to show you the question papers. You have to take the screenshot of those and use them for practicing. Here, this is maths question paper. It was conducted for 15 marks. Total 8 questions are there and all are important in the examination point of view. And this is science question paper conducted for 12 marks. Here also 8 questions are there. All important questions are implemented in this. Please do practice. Dear students, now let us focus on our today's class. In science we were discussing the chapter electricity. Let's go for continuing. As we all know that in this chapter we are focusing on some important physical quantities. Could you recall them? All the physical quantities one after the other in order? Yes. Are you ready? Now I am going to make you to recall them with a simple activity. For this activity, here I am using the chart. Observe. What is the first physical quantity we discussed in the chapter electricity? Yes, you can guess it. You are right. It is electrical energy or electricity. The energy acquired by the charged particles because of their motion. And what about its SI unit? It is joule. And second one is, it is charge, the property of a particle which is responsible for electrostatic force, right? What is its SI unit? It is Coulomb. Then total number of charged particles present in a body is called the quantity of charge, denoted by the symbol Q, and the formula is Q equal to N into E, right? Yes. Then could you tell how many charged particles will represent 1 coulomb? Yes, there are 6.25 into 10 raised to the power 18 electrons charges, that is equal to 1 coulomb. And which is the third physical quantity? Yes, this is electric current. And the rate of flow of electric charges is called an electric current. And the formula is, very good, I equal to Q by T or I equal to NE by T, because Q is nothing but NE. Then what about its SI unit? It is ampere. Then what is actual unit? It is coulomb per second. Next, fourth physical quantity that we had discussed was, it is electric potential. The work done in bringing a unit positive charge from infinity to the given point in an electric field, right? Then what is its formula? Guess it. V equal to W by Q. What about its SI unit? It is volt. Then actual unit by using formula is joule per coulomb. And one more physical quantity, it is fifth one, almost equivalent to electric potential. What is that? It is potential difference. What is the other name? Most familiar one, voltage. Recall the definition. The work done in moving a charged particle, that is unit positive charge, from one point to another point in an electric field, right? Then what about the formula? Same formula will be used, that is V equal to W by Q. Its SI unit is volt and other unit is joule per coulomb. Got it? Next, sixth one is, we all know that if the charged particles have to flow in the circuit or in the conductor continuously, then there must be a potential difference between the ends of a conductor. That is provided by a source which is called EMF, Electro-Motive Force. Definition is, the energy, the minimum energy required to maintain the constant potential difference between the ends of a conductor is called electromotive force. Then what is the source of EMF? Yes, you are right. It is electric cell or battery. Another important term which opposes the flow of electrons in the conductor. What is that? Yes, correct. It is electric resistance. The property of the conductor which opposes, due to which it opposes the flow of electrons to pass through it, is called electric resistance. It can be found out by using the formula R is equal to V by I. What about its SI unit? It is ohm. Got it? Or volt per ampere. Then we have, these are the important physical quantities, right? Then after that we learned one of the important statement which gives the relationship between V and I. What is that? Yes, you are right. It is Ohm's law. Then what is the statement of Ohm's law? Ohm's law states that in any conductor at constant temperature, the current flowing through the conductor is directly proportional to potential difference between the ends of a conductor, right? So hence the mathematically it can be written like this. It is I is directly proportional to V, or V is directly proportional to I. The ratio of V by I is what? V by I is constant. What do you call this constant? It is electric resistance. Hence we write R is equal to V by I. Got it? Then even we had drawn the graph of V and I, this is x-axis, and V, the y-axis. We have got the graph. What is the nature of the graph? Yes, it is straight line, nothing but linear. Hence, we can say that the ratio of V and I is constant. The slope of the graph is nothing but V by I, which is equal to R. So, this much was discussed in the last class. Now, let us go for continuing. Here, one formula is there which gives the relationship among R, electric resistance, V, potential difference, I, an electric current. What is that? It is R equal to V by I, or V is equal to I into R, or I is equal to, it is V by R. These are the formula. Here, one important physical quantity, that is capital R. What it is? Electric resistance. We have also learned that the factors on which electric resistance depend, right? What are those? It depends on, first one is length, second one is area of cross section, third one is temperature, and fourth one is nature of material of the conductor. Got it? Then even we have come to know how these factors are responsible. As the length of the conductor increases, electric resistance also increases. Hence we write R is directly proportional to L. Then second term is area of cross section. As area of cross section of the conductor increases, nothing but when its thickness increases, electrons will get more space for their movement. Hence electric resistance decreases, obviously current increases. Then as the area of cross section decreases, electrons will get less space for their movement. Therefore, electric resistance increases and current decreases. Therefore, we write R is inversely proportional to area of cross section. And third one is temperature. As the temperature of the conductor increases, then electrons will get more obstruction from the atoms. Therefore, electric resistance increases. We can write R is directly proportional to T. And another one is nature of material of the conductor. So, electric resistance is different for different materials. Now, just again you go through. In that, let us discuss some more points. Suppose you are going to take a wire. It has some electric resistance, right? If this electric If the length of the wire is doubled, see that I have taken two wires of same length and same kind. Then when the length is doubled, then we know that electrons will get to more opposition for their movements. What about the electric resistance? Electric resistance increases, current decreases. I'll write that here. Here, as when the length is doubled, electric resistance increases by 2 times. Got it? Then what about the current? Current obviously decreases because electric resistance is increasing. Clear? So current decreases. If length is reduced to half, when length is reduced to half, then what about the electric resistance? Look here, this is the length. I am going to reduce it. Just go for considering only this much. So electron should flow only in this length. Hence they get less amount of resistance. Therefore electric resistance also decreases by half. I can write like this. When the electric resistance decreases, what about the current? Current increases. Clear? Now come to area of cross section. If the thickness of the conductor is increased by 2 times, when it is doubled, if it is first this much only thickness, now it is increasing, electrons will get more space for their movement. Hence resistance decreases. Got it? When resistance decreases, current increases. Here are when area of cross section is doubled, electric resistance decreases by half, then current increases. Suppose area of cross section is reduced to half. Alright, area of cross section is reduced to half. That means this much is there. Now thickness is decreased. Thickness is decreased. Electrons will get only less space for their movement. What about the electric resistance? Electric resistance increases. Current decreases. So here I write electric resistance increases, then current decreases. Got it? Now I am going to take the wire. The wire is going to be stretched like this. On stretching, what will be the electric resistance? Whether it increases or decreases? Yes, you are right. Electric resistance decreases. How? On stretching, the thickness of the wire decreases. Electrons will get less space for their movement. Hence, electric resistance increases. When electric resistance increases, again the current decreases. Look here, on stretching the wire, you can say that electric resistance increases, then current decreases. Clear? Now, one more important thing. Another point is to be discussed. I am going to take both. You are going to take a wire of some thickness, of some length. The length of that wire is to be reduced to half. When it is reduced to half, then what about the electric resistance? Very good. Electric resistance decreases by half because length is decreasing. Next, another one is when area of cross section is doubled. When the area of cross section is doubled, what happens? Very good. As thickness increases, electric resistance decreases. Electric resistance decreases to again half. Then altogether, what is the total amount of electric resistance decreases? You are right. It is R by 4. That is 1/4 of R. Clear? Electric resistance decreases by 4 times. 4 times means, suppose if it is 100 ohm, it comes to 25. If it is 10 ohm, it comes to 2.5. If it is 4 ohm, reduced to 1/4 means it comes to 1 ohm, like this. Now, what about the current? When large amount of electric resistance is reduced, hence obviously more amount of current flows in that conductor. Clear? So, when you are copying this one, you have to write like this. Electric resistance, then point wise, first point is like this. When length of the conductor is doubled, then electric resistance increases by 2 times, hence electric current decreases. Like that you have to make the point for all this. Next one, another, we all know that experimentally we have come to know that electric resistance is directly proportional to length. Correct? You may call this as statement 1. Then we also know that electric resistance is inversely proportional to area of cross section of the conductor. You may call this as second statement. Now from 1 and 2, how can it be written? From 1 and 2, we can write these two statements combined as R is proportional to L by A. Then what is this? This is proportional. Let us go for removing the proportional. Means I am going to place equal sign. To remove this proportional, we have to assume the proportionality constant. Okay. R is equal to rho into L by A. That is rho. Can be written as like this. Rho, RH, rho. Then what is this proportionality constant? And this proportionality constant is known as, it is resistivity. Got it? Later we shall discuss about resistivity. Now, I am going to solve this resistivity. Rho is equal to cross multiply A, R into A by L. And this is the formula used to find out electric resistivity or simply resistivity. Clear? Or specific resistance. Rho equal to R into A by L. And this is one of the important questions to be asked in the examination. How? They will ask you to derive the formula to find electric resistivity or specific resistance. I will write it as it is. Derive an equation for electric resistivity or simply just resistivity, also called specific resistance. So then what are the things you have to write? First statement in this way. We know that electric resistance is directly proportional to length of the conductor. Then you will write the symbolic statement. Next, electric resistance is inversely proportional to area of cross section of the conductor. Then you will go for writing R is proportional to 1 by A. You will call this as second statement. Next, from 1 and 2, R is proportional to L by A. To remove this proportional, we have assumed the proportionality constant, which is called resistivity. Then rho, on solving rho, you will get RA by L. Clear? Next, another question was asked in the examination regarding this only. What it is? It is, the question was, find the SI unit of resistivity. Here I write, question, find the SI unit of resistivity. This is also very important one. There is a chance of asking in the examination as well. Now let us come to know how this is. We all know that the formula used to find out resistivity. It is rho is equal to R into A by L. To find out the SI unit of resistivity, you must know the SI units of these three physical quantities already we are very familiar. Now here I'll write SI unit of first one R electric resistance. What is that SI unit? Correct. Ohm. A is area. Standard unit of area, it is square unit. SI unit, it is meter square. What about the length? It is meter. Clear? Now the SI unit of rho, SI unit of rho can be written like this. See that R, ohm, A, meter square, then L, meter. Meter and meter get cancelled. It's equal to ohm. Clear? Sorry, ohm and another one meter. Conclusion. Therefore, the SI unit of resistivity is ohm meter. All these letters should be in small letters. These are all. Then symbolically it can be written as omega m. Very important one. Please don't forget. Do remember. Now here we are using the word resistivity. Then you all may be thinking that, so what is that resistivity? Dear students, we have already come to know the factors on which electric resistance depend, right? In that, the fourth factor is resistance of a conductor depends on the nature of material of the conductor. Here I have two wires, two kinds of wires. See, this is an iron wire. It is an iron wire. And this is a copper wire. This is copper wire. Then we know that in both the wires, iron and copper, what are present inside them? Atoms will be there. Here copper atoms are there, and in this iron atoms are there. If it is so, assume that electrons are moving in that. In which of these two will oppose obstruction, that it will oppose electrons in them, whether copper or iron? Yes, you are right, it is iron. How do you say that it is iron? The reason is, in iron, the atoms are packed very tightly. So, electrons will get obstructions oftenly. Hence, they possess more electric resistance. Whereas in copper, there also atoms will combine tightly but lesser than in iron. So, electrons can flow easily in copper than iron. From these two examples, can we say that the resisting power, nothing but opposing power is different for different conductors? Yes, it is right. So, this resisting power of a conductor can be expressed quantitatively by a physical quantity that is called resistivity. Got it? Just I am telling you the meaning, not actual definition. Meaning is, it is resistivity means the measure of resisting power of a conductor. The measure of resisting power of a conductor can be expressed quantitatively by a physical quantity that is called resistivity. Here I write resistivity. Then what is the actual definition of resistivity? Now let me tell you that. Look here. Here I am going to take a conductor. In this, let us take this as copper. Dear students, here I have taken two wires. One is made of copper and another one is made of iron. Even you may go for taking silver. See that? All are of same length and their area of cross section is also same. Then could you tell which of these three will oppose more to the flow of electrons? Copper, iron or silver? Yes, It is iron. So electric resistance is much high in iron. Then least one, whether copper or silver, which of these three will oppose least to the flow of electrons or charges? It is silver. And the electric resistance of silver is less. Hence, we say that it is the best conductor of electricity. Got it? Now, all these have their own electric resistance. They have their own electric resistance because the opposing power is different for different one. When you go for taking only copper, any length, any thickness, got it? I'll go for taking some number of copper materials, some number of copper wires. This is first wire, this is second wire, this is third wire. All these are copper only. And I have taken same length and same thickness. Then the resisting, what do you say about the resisting power of these three? Will it be same or different? It will be same, right? That is nothing but resistance, the opposition offered for the flow of electrons. Hence, we can define the resistivity as the resistance of a conductor of unit length and unit area of cross section. So this is the definition of resistivity. I go for writing it. So you just observe here, the resistance of a conductor, of unit length and unit area of cross section. Unit area of cross section is called resistivity. Got it? Then you can also write the meaning. Meaning of this resistivity is, it is the quantity of measure of resisting power. Quantity of measure of resisting power. That is the meaning. Now, what is its formula? Formula is, it is just, we have already derived, rho equal to R into A by L. Then what about its SI unit? SI unit is, it is ohm meter, or symbolically omega m. Then does it depend on any factors? Yes. Does it depend on length? Does it depend on area of cross section? No. If you go for taking any number of copper wires, then having same length and same thickness, all will be having same resistivity. When you go for taking iron, any number of iron wires can be taken of same length and same thickness, all will be having their own resistivity. Got it? So resistivity is different for different materials. Hence we can say that it depends on one factor, that is nature of material of the conductor. And another factor is there. You will go for taking copper wire of same length and same area of cross section. Two such copper wires are taken. One is at 20 degrees Celsius and another one is at 26 degrees Celsius. Will they show same resistivity? No. It depends on the temperature. Hence, another factor on which resistivity depends is temperature. So, these are the two factors on which electric resistivity or specific resistance depend. Here I write factors on which resistivity depends. Then, what are those? First one is nature of material of the conductor. Nature of material of the conductor, and another one is temperature of the conductor. Temperature Then just one simple question. What will be the resistance of the conductor as the resistivity increases? Means when the resisting power, nothing but opposing power increases, the resistance also increases. Got it? Hence we can say that as resistivity increases, resistance also increases. As resistivity decreases, resistance also decreases. Clear? I'll give you some more information. So now you have to copy from here to there with the same order. See that this is. So earlier I had left the gap because we discussed about, we got information about resistivity. I have written them. I came back to write the definition of resistivity. So first you copy this one, and this is second one, this is third one, and this fourth. Copy that. Okay, look here. Here I have written resistivity of some of the elements: copper, silver, and iron. Observe copper 1.62 into 10 raised to the power minus 8 ohm meter. Silver 1.60 into 10 raised to the power minus 8 ohm meter. Iron 10.0, or just you can write 10 into 10 raised to the power minus 8 ohm meter. So these are all the different elements having different resistivity. Among these, which is best conductor? It is silver. Why? Because the resisting power is less. As the resistivity decreases, resistance also decreases. Hence, the current can flow easily. Clear? And so, and another one. In general, metals. When you go for taking the metals, in general, we can write the resistivity of the metals as range like this: 10 raised to the power minus 8 ohm meter to 10 raised to the power minus 6 ohm meter. As the resistivity is less, and these will be used for transmission wire, particularly copper and aluminium. These two will be used for domestic wiring. Next, for insulator, in insulators, electrons cannot move easily. There will be lot of obstruction, opposition for the flow. Hence, the resistivity of such insulators will be from 10 raised to the power 12 ohm meter to 10 raised to the power 17 ohm meter. Please do remember these 2 points. In the examination, they may ask the question that write the range of resistivity for metals or conductors, and insulators should be written. Clear? And when you go for taking the alloys, if two or more metals combine completely, nothing but the homogeneous mixture of two or more metals is called alloys. In alloys, there will be constituent elements. When you compare the resistivity of the whole alloy with each of the metal used as a component, alloy's resistivity will be more than each of these components. Here I have taken some of the examples. Constant 10. It is an alloy. The component elements are copper and nickel. Then nichrome, nickel, chromium, manganese and iron. These two four together make nichrome. Manganese, it is copper, magnesium and nickel. These are the three elements present, particularly metals present in this. Got it? And another important thing is, usually the alloys are used for electrical heating devices. When you go for taking the heating devices like it may be an electric iron box, in that a coil will be there. That coil is nothing but nichrome. When you go for taking a fuse, in that also there will be an alloy which is made of tin and lead. Got it? Why they are to be used? Now let me go for telling you that. So alloys are used in electrical heating devices. there is a reason. Electrical heating devices or in general heating devices. What are those reasons? The reasons are, the very first thing is they have high resistivity. They have high resistivity. As they have high resistivity, then obviously resistance will be more. As resistance increases, there will be friction between the charged particles and the atoms will also be more, which produces the heat. Got it? Then another thing is, these alloys do not get oxidized or they do not get burnt even at high temperature. That is also another important point. They do not get oxidized even at high temperature. Followed? These are the two important points to say why alloys are used in electrical heating devices. Please do remember, very important point in the examination point of view. Next, another one is, we go for using some filaments in some devices, electrical devices. For example, in an electric bulb. Name the filament used in electric bulb. It is tungsten. It is exception in case of metals. It is not an alloy. Why tungsten will be used? What do you say about its electric resistance? It will be very thin. So it has high electric resistance and high melting point. That is why even when very good amount of current flows and the tungsten get heat up, it will not burst the bulb, because nitrogen will be filled in that to give it a long life. So filament in electric bulb is, what is that? It is tungsten. What is the reason for using this tungsten? One is, it has high electric resistance, and second one is, it has high melting point. These are the two reasons. Okay. So now, please copy from here to here quickly. Okay. Dear students, so far we come across many physical quantities. Now we will focus on numerical problems. They are also very important in the examination point of view. Observe. First I have taken textbook problems. This is first one. Don't go for copy. Observe. First one is, how much current will an electric bulb draws from a 220 volt source if the resistance of the bulb filament is 1200 ohm. See, I have told you many times, when you are solving any problem in physics, particular or in general science, so observe the given statement, identify the data, then go for considering the units. This is very important. Here I'll write data. What has been given? How much current will an electric bulb draw? What you are going to find out? It is current. Current is denoted by I. Right? This is going to be found out. From a 220 volts, see that 220 volt is there. Means what it is? It is the magnitude of the physical quantity. Voltage, nothing but potential difference. Here I write V is equal to 220 volt. If the resistance of the bulb filament is 1200 ohm, here 1200 ohm is equal to what it is? Ohm is the unit of electric resistance. I can write R. Now, to find out this I, could you tell which formula can be used? The formula which includes V, R and I. What is that? Very good. It is from Ohm's law. that is R is equal to V by I. By Ohm's law, we can write R is equal to V by I, where V is 220 and I is 1200. 0, 0 get cancelled. So we are finding I. Sorry. Now, alright, of course, the ratio we had taken was same only. Let us solve I. I is equal to V by R. What is V? V is 220. And R, it is 1200. 0, 0 get cancelled. Both are even, cancel them by 2. 1s are 1s are, then 6 are 0s are. 11 by 60. So start dividing 11 by 60. 11 by 60, not divisible, put decimal, take 0, 110. 1s are 60, 1s are 60. 5 will remain, and 0, 50. Then again take 0. It is 500. 60, 8s are 480. Then 20 will remain. You may take 200. 63s are 180. Again 20, and it will be recurring. That is 0.18333, and so on. Approximately we can write 0.18. Then what is the unit of current? Unit of current is ampere. Clear? So this is approximate value. Hence we can write that the amount of current drawn is 0.18 amps. Now go through second one. Do concentrate here. How much current will an electric heater? How much current will an electric heater coil draw from a 220 volt source if the resistance of the coil is 100 ohm? It is also of same type. So you just go for telling the data. What is? How much current? What you are going to find out? You are right, it is I. Will an electric heater coil draw from 220 volt? What does 220 indicate? It is voltage. V is equal to 220 volts. Then if the resistance of the coil is 100 ohm, the 100 ohm is, it is electric resistance, R equal to 100 ohm. Again, you can go for using the formula. By Ohm's law, we can write R is equal to V by I, but we want I. I is equal to V by R, where V is 220 and R is 100. It is very simple. 0, 0 get cancelled. 22 by 10. And don't go for cancelling by 2. Because denominator 10 is there. You can write it directly as 2.2. Current is 2.2 amps. So this much amount of current is drawn by electric heater coil. Understood? So these two are important one. Now by pausing the video, you have to copy from here to here. Copy. Okay, let's move on to third one. Observe. Potential difference between 2 points of a wire carrying 2 amps of electric current is 0.1 volt. See that? 0.1 volt. And here 2 amps. Calculate R. Very simple one. They only have given. Then what do you write in data? Yes, 2 amps. What it is? Which physical quantity it is? Ampere is the SI unit of current. Hence we can write I equal to 2. Then what does 0.1 volt indicate? 0.1 volt. It is voltage, nothing but potential difference. You are going to calculate R is question. Now calculation, again you can go for using Ohm's law. According to Ohm's law, how do you write? R is equal to V by I. You are going to find out R. Directly you can go for taking substitution. What is V? V is 0.1 volt divided by I. I is 2 amps. And one more thing you must remember, here what are the physical quantities we have taken there, and those have been given in SI units only. So no need to worry about the units. Next, here 0.1 by 2. this can be written as, after decimal one digit is there, so 1 by 20. Clear? If you do not know, you can follow this one. 0.1 is 1 by 10 whole divided by 2, and this is 1 by 10 into, take the reciprocal of the denominator, it is 1 by 2. 10 2s are 20. You can write it directly like this. So 1 by 20, divide 1 by 20. So zeros are. So I go for showing in this way, better to understand like this. 20. 1 is not divisible by 20, so put decimal, take 0, it becomes 10. 10 is not divisible by 20, take one more 0, it is 100. By taking 0 here, we have taken one more 0. 20 how much? 100. 5 is 100. It is 0. Now, it is 0.05. Then what is the resistance? It is 0.05 ohm. That is the conclusion. Clear? Now, let's move on to fourth one. This is the important one. I am going to put double star mark. Look here. Go through the statement. The potential difference between the terminals of an electric heater, the potential difference between the terminals of an electric heater is 60 volt. Then, when it draws a current of 4 amp from the source, 4 amps from the source, then what current will the heater draw if the potential difference is increased to 120 volt? Understood? When the heater is connected in the circuit with a potential difference of 60 volt, it will draw a current of 4 amps. If it is connected in 120 volt, how much current it can draw? That is going to be found out. One important thing that you can observe is electric heater. The same electric heater will be used in both the cases. That is, first one, when it is connected between 60 volt, potential difference of 60 volt, and another one is the same electric heater will be connected in 120 volt. So, electric heater has some electric resistance. Whether this electric resistance changes in both the cases? No, it will be same. So R is same in both the cases. Here I write in data. First, case 1. In case 1, voltage is 60 volt and 4 amps is given. It is current I equal to 4 amps. We have to find out electric resistance of the heater. Then in case 2, voltage is given V equal to 120 volt. You are going to find out what current will the heater draw. I equal to question mark. Look here. Here in calculation, according to first case, when the electric heater is connected in 60 volt, then we have to find out the electric resistance of that heater. So by using Ohm's law, we can write R is equal to V by I. Then what is V? V is 60 volts. Current, it is 4. This is equal to, you can cancel it by 4. 4 ones are 4 ones are 2 will remain 20. 4 5s are. It is 15 ohm. So electric resistance of the heater is 15 ohm. Clear? Okay. Now if this heater, an electric heater having resistance of 50 ohm is connected in 120 volt, then what amount of electric current it draws? Let us go for finding it out. Here I am writing, when the heater is connected in 120 volt. Let us see that. Again by using Ohm's law, R is equal to V by I. You are going to find out current. I is equal to V by R, right? What is V? V is 120. What about the resistance? It is 15. It's equal to 15 ones are 15. Directly you can write it. How much are? 8 are. Or else, if you want to extend this, 5 3s are 15, 5 2s are 10, 2 will remain 20, 4s are 24 by 3 is nothing but 8 amps. So I is equal to 8 amps. You can write the conclusion as, therefore the amount of current drawn by the electric heater when it is connected in 120 volt potential difference is 8 amps. Clear? So now you have to pause the video and start copying from here to here. Copy. Observe here. Again, we are moving to another problem. This is fifth one. It is just like previous one. There we had used electric heater. Now here we are using electric iron bars. Go through the statement. An electric iron draws a current of 3.4 amps from the 220 volt supply line. When it is connected in 220 volt supply line, how much current it will draw? It will draw 3.4 amps. What current will this electric iron draws when connected to 110 volt supply line? Got it? So here, whatever the electric iron we are taking, when you may go for connecting it in either 220 volt line or 110 volt line, then which physical quantity will be same? Yes, you are right. It is electric resistance. So it has same electric resistance. So voltage may be different, current may be different, but the resistance will be same. Do you know the resistance of this electric iron? Unknown. Now first let us go for finding it out. Here in data right, there are two cases. What are those two cases? In first case, it is connected in 220 volt. 220 volt supply line. Second case, it is connected in 110 volt. I am going to write both. Data according in the first case, you can write an electric iron draws a current of 3.4 amps. So I is equal to 3.4 amps. In case 1 you can take I1, R1, V1 like that. Or else if you mention case 1, not necessary. I equal to 3.4 amps from the 220 volt. So V is equal to 220 volts. Then we do not know which physical quantity? Yes, it is R. R is unknown. When R is known, then you can go for second case. What is that second case? Yes, you all may be thinking that when this iron, electric iron is connected in which supply line? It is 110 volt supply line. So here I write voltage is 110 volts. With this information you are going to find out the current that is drawn. Now let us go for calculation. In calculation, first case, what is that? Electric iron. When electric iron is connected in which supply line? First case, it is 200 volt supply line. Let us go for this. Here by using which law? It is Ohm's law. According to this, how do you write R? R is equal to V by I. Then what is V? V is 220. Current is 3.4. Let's go for dividing. It is 220 divided by 3.4 is there. Write it as 34. After decimal 1 digit, in numerator you can take 1 0. Then start dividing. Both are even numbers. You can divide it by how much? 2s are 2. 17s are 2. 1s are 1s are 0s are 0s are. You may express that in decimal form or not. It is left to you. If you want to express that in decimal form, you have to divide 1100 by 17. So let it be as it is. It may helpful in the further calculation. So I have kept it as it is. Next, second case, that is when electric iron is connected in 110 volt supply. Yes, we have to use again the Ohm's law. Now according to Ohm's law we can write R is equal to V by I. But what we are going to find out? You are going to find out current. I is equal to V by R. Then what is V? You can observe that V is 110. It is when electric iron is connected in 110 volts. Hence voltage will be 110. What about the resistance of the electric iron? It is 1100 by 70. Alright, it is equal to volt divided by 1100 divided by 70. To make this calculation simple, I will write 110 in the numerator as it is. Then denominator 1100 by 17 is there. Convert this into multiplication. So therefore you have to take the reciprocal. 17 by 1100. Now see that 0 0. Then it is 11 into 17 by 110. 11 ones are 11 how much are 110? It is 10s are. So 17 by 10 here apply. So 17 by 10 is nothing but 1.7. So I is equal to 1.7 amps. Got it? So what amount of electric current that electric iron box draws when it is connected in 110 volt? It is 1.7 amps. What about when it is connected in 220 volt? They only had already given, that is 3.4 amps. Clear? So this is also one of the important type of problems. So now you have to copy from here to here. Dear students, I think you might have copied this. Okay, before concluding the class, just I make you to recall the points what we learned today. Particularly we focused on resistivity. And second point is how electric resistance changes as length and area of cross section changes. And along with that, how the current also changes. All these points are known to us. In addition with that, today we have solved some problems on Ohm's law. R equal to V by I. Okay. Tomorrow we are moving to solve some of the important problems on resistivity. So please work out on resistivity concept what we have covered today. Don't keep anything pending. So work out whatever we have covered on the same day itself. So with this, let us stop. Thank you.